Let's continue section 4.3 with the graph of the cotan function. Here, we're given an a in front of my function that has a value of 2. Recall from the previous slides that our cotangent function has special points that go from 1, 0, then -1. But this 2 is going to change that value to 2, 0, -2. Now what we do is we follow the same procedures that we have in the past, graphing our other functions. So what we need to do is to find the period. The period of a cotangent function is going to be pi over b. Here our b is 3, so my period is pi thirds. Then I find my quarter point. I do that the same way I have in the past by multiplying by pi thirds times 1/4. That will give me pi over 12. Now I need to find the asymptotes. And our asymptotes are a little bit different than the values for my tangent function. Here they have bx equal to 0, solving for x equals 0 over b, and we also have bx equal to pi. And then I solve for x, which is going to give me pi over b. Now all I need to do to find the asymptotes is substitute in the value of b. Here, 0 divided by 3 is still x equals 0. And also I have pi divided by b, which will give me x equal to pi thirds. I've created the coordinate plane. Recall that I count by our quarter points, so 1 pi over 12, 2 pi over 12, 3 pi over 12, till our period, which is 4 pi over 12, which is pi thirds. Now I have my asymptote at 0 and pi thirds. So I'm just going to drop my asymptote at those locations. And pi thirds is going to be at 4 pi over 12. And now I have my special 3 points on the interior of my asymptote. And we start with 2, 0, and then -2. Then I continue on the left side of the origin, and that will give me an asymptote still at 0 and a negative pi thirds. And again, my 3 points in the interior that give me my special values of 2, 0, -2. And then graph. Notice here how I've plugged this value into my calculator. Remember, this is cotangent, so the reciprocal value of that is 1 over tangent. The 2 still is in the numerator, so I have double parentheses at the end. Then I set my window as normal, and then I graph. I can check a value. Here I'll try pi twelfths. I should get a value of 2 to make sure that my graph is correct, and I do. Our next example, y equals a -2 minus 1/2 cotangent 1/4 x. Recall that our key points for cotangent are going to be 1, 0, and a -1. But the a value in front of my cotangent is a -1/2. So this gets flipped, and the value is a 1/2. So that gives me a -1/2, 0, and 1/2. Then we continue with the problem as usual by finding the period. So here, the period is going to be pi over b, which is pi over 1/4, which equals pi divided by 1/4. Then we invert and multiply, which gives me 4 pi. Then we find the quarter point as usual by multiplying the period by 1/4, which gives me pi. Now we find the asymptotes using the formulas for cotangent. Here, x equals 0 over b, so 0 over 1/4 is still going to be 0, and x equals pi over 1/4. We already calculated that value for the period. This just turns out to be 4 pi. I set my coordinate plane using my quarter point. Now what I wanted to do is drop my vertical asymptotes and then graph the key points. So it's 0, and at 4 pi, Then my key points are a negative half, 0, and then a half. And this is going to graph just our original function of a negative 1/2 cotangent 1/4 x. Now I need to graph the vertical shift of a negative 2. Therefore, each point needs to drop 2 units from a negative half to a negative 2.5, 0 to a negative 2, and a positive half to a negative 1.5. Let's verify using a calculator. Here I have a negative 2 minus 1/2. Then for cotangent, it's 1 over tangent of 1/4 x. I set my window as usual. And here's the graph. Let's calculate a value. Here I'm going to check pi. That should end up being a negative 2.5. And it does, therefore my graph is correct. Our next example, y equals cotangent x over 2 plus pi. First of all, our value for a in front of our function is 1. Therefore, our key points being used are going to be 1, 0, negative 1 for cotangent. Then I need to find my period. But recall, when I need to find my period, my value of my coefficient for my x needs to be a positive 1. Here it is a half. So what I need to do is to factor the function to get that value to be 1. So I'm going to factor out a 1/2. And when I do that, that will leave me inside the parentheses x plus 2 pi. I can verify this by distributing back through. 1/2 times x is x over 2, and 1/2 times 2 pi is going to give me pi. Now I continue with the period, which is still going to be pi over b. And here my b is the value inside the function, which is a half. So pi over 1 over 2, which equals pi divided by 1 over 2. Invert and multiply gives me 2 pi. Then finding the quarter point, I multiply my period by 1/4. So that's 2 pi times 1/4, which gives me pi over 2. Now I find my asymptotes as usual. Bx equals 0, x equals 0 over b. When I substitute in, x is still going to be 0. Bx equals pi. Therefore, pi over b, when I substitute in, that gives me pi over 1/2. We've already calculated that to be 2 pi. Since I have a quantity inside of my function, this means that my graph is going to shift to the right or left depending on this value. Therefore, I need to solve that value for 0. And when I do that, x equals a negative 2 pi. Therefore, my graph will shift to the left, or a negative value, by a 2 pi unit. So to do this, all I need to do is start with my original asymptote of 0. 0 minus 2 pi gives me a negative 2 pi for my first asymptote. Then 2 pi minus 2 pi gives me my next asymptote at 0. Now I graph my key points, which are going to be at 1, 0, and negative 1. Then I can continue with the next asymptote, which, since this is at 0, my next one will be at 2 pi. And again, graph my key points. Let's verify using a calculator. Cotangent, which is 1 over tangent, x over 2 plus pi. Setting my window as usual, and then graphing. Let's verify a value. I'm going to test 3 pi over 2, which I should get a negative 1. And I do, therefore my graph is correct. Our next example, y equals a negative 2 plus 3 cotangent 4x plus pi. Here my value for a in front of my cotangent is 3. Our usual key points for cotangent for a positive value is 1, 0, and negative 1. Here, since this is a positive 3, it will be 3, 0, and negative 3. Now, I determine the period, but what I need to do first is to get my coefficient inside my function to be a positive 1, so I need to factor. So y equals a negative 2 plus 3 cotangent, factoring of 4, that gives me x plus pi over 4. I can distribute back in to verify my solution. 4 times x is 4x, and 4 times pi over 4 will get pi. Now, all I need to do is to find my period. That will be pi over b. Here, b is 4, so pi over 4. Then my quarter point will be my period times 1/4. Pi over 4 times 1/4 gives me pi over 16. We continue by finding the asymptotes. Here I have bx equals 0, or x equals 0 over b, therefore x is going to be 0, or bx equals pi. Substituting in, I get pi over 4. When my function has a quantity on the interior of the function, that tells me I'm going to have a phase shift to the left or right. Therefore, I have to set that quantity equal to 0 and solve. So x plus pi over 4 equal to 0 and solve. That gives me a negative pi over 4. Therefore, my graph will have a phase shift to the left because of the negative value. Now what I've done is created my asymptotes on the graph. So what I did was take my phase shift of a negative pi over 4, 0 minus pi over 4, which would give me a negative pi over 4, put an asymptote, and then at pi over 4 minus pi over 4 goes to 0, and then another pi over 4 units would go to my pi over 4 to the right of the origin. Then I created my key points of 3, 0, and negative 3 for my original function of 3 cotangent 4 x plus pi, and I graphed those, completing a smooth curve. Then what I need to do is create a vertical shift down 2 units because of this negative 2. Here, this unit is at 3. It drops 2 units to 1. 0 goes to a negative 2. And 3, negative 3, goes to negative 5. And then we graph. Similarly, on the right side, I am at 3 units, dropping 2 units to 1. 0 goes to a negative 2 units, and a negative 3 goes to a negative 5 units. Let's graph the function to verify my solution. Here, a negative 2 plus 3 cotangent, of course, is 1 over tangent of 4x plus pi. Then we graph the function. Let's verify a point. Here, a negative pi over 16 is at a negative 5. And I check that using a calculator, and I get the same value.